everybody, my name is Coca, and today we'll be doing a question from the questions and problems section of Chapter 7 of our book, University Physics for the Life Sciences. The preview of this question is, this question falls under the purview of Section 7.3, Rotation of a Rigid Body. So if any of this is unfamiliar, or maybe doesn't make sense, you can definitely look there for review. Moving on. Today I'm doing question 29. Question 29 is relatively simple. It's quick and easy. It states, a vinyl record rotates on a turntable at 45 rotations per minute. What is A, the angular speed in radians per second? And what is the period of the motion? And since the period of the motion is the amount of time it takes for a revolution to occur, and we measure that in seconds since it's a measurement of time. And I think that I'm going to want to start with part B. Part B seems like an easier place to begin, mainly because we know that period of the motion, t, is actually inversely related to frequency. We know that the frequency is the amount of rotations that can occur per second. So luckily for us, this measurement right here, rotations per minute, can easily be converted to a frequency. And once we have our frequency, we can find our period. All right, so we have 45 rotations per minute. We know that there are 60 seconds in a minute. So let's divide the amount of rotations that occur in that minute by the 60 seconds in the minute. And when you do that, you get 0.75. 0.75 revolutions per second. Now we know that this equals our frequency. Let me fix that really quick. Mess that up. There we go. That's better. And since we know that 0.75 is our frequency, we know that 0.75 is the inverse of our period. So we can go ahead and place 0.75 in for our frequency up here, and we can get our period. And what you get when you divide 1 by 0.75 is about 1.3 seconds. Now, it's not actually 1.3, it's actually 1.333, but significant figures and also rounding. So we're not gonna, write out too many threes. So yeah, so quick and easy. Our period is 1.3 seconds. We did that by finding the frequency, by converting rotations per minute to rotations per second. And then finding the inverse of our frequency, which is our period. Cool. So now that we found the period, we can very easily find the angular speed. The angular speed is, put this here. The angular speed is just the magnitude of our angular velocity, so chubby W. And we know, because we're happy little physics kids, we know that this chubby W is equal to 2 pi over t. Wow, look at that. Beautiful, gorgeous, because we know the period already. So if we want to find our angular speed, all we have to do is put the period into this equation. Simple, easy, amazing. So 2 pi over 1.3. Now what we're doing here is we are basically finding the rate of rotations in radians. 1 revolution in radians. And we're dividing that by the time it takes for 1 revolution to occur. So in order to find the rate that the vinyl record is spinning, which is our angular speed, since speed is the rate of distance over time, our distance is our spinning, our turning in radians, and then our time is our 1.3 seconds, our period. And so when you do that, you can put that into your calculator and just get, I messed that up, I think. 4.8. Let me check my calculator. And it's all the way across the room. But yeah, 4.8 radians per second. All right, that is basically the whole question. Quick, easy, not a problem. Just to go back over what we did, we found our period first by converting 45 rotations per minute to a frequency of revolutions per second. And then we used that frequency to find the period because they are inversely related, or inversely proportional. And then we used our period to find the angular speed, which we know is equal to 2 pi over t. And that's it. I hope you have a wonderful rest of your weekend, guys. Thank you for listening. Have a wonderful day. Bye.